Alright, good morning. I just wanted to share a quick little video to help with the technology side of finding zeros and extreme using the calculator. So please notice here's a function in Delta Math where I am finding the zeros of this quadratic, and I'll show you how to use Desmos in a second, but first I just want to use the inspire because again this is what you'll have on your test. So 0.1x squared minus 0.4x minus 2.2. One word of caution is please make sure you check it, make sure that it's all typed in correctly, otherwise things will get frustrating. Now, when you have a graph like this, please be careful because it may look like 1, 2, 3, 4, 5, 6, 7 is my 0, right? I'm using that x-intercept to identify the 0, but please notice if you go to menu, which is what does all the cool stuff, and you analyze your graph, there's literally the option of zeros, right? Now, when it pulls this up and asks for a lower bound, you're going to make sure that your cursor is to the left of the x-intercept or 0 that you want. You just hit enter, and then upper bound, you go a little bit to the right, and then you hit enter. Okay, and so there's my 0. Please do note that the question specifically asks to round to the nearest thousandth. That is the third decimal, so 7.099. So x equals 7.099. I believe, we'll find out in a second, yep, if you hit a comma, it automatically gives you a chance to do a second x-intercept. So menu, analyze graph again, 0. And so notice I can only do 1 0 at a time. And so I go to the left and to the right of each of the x-intercepts, just hitting enter. So let me do that a little bit more slowly. Once I get to the left of the x-intercept, I hit enter, go to the right of the x-intercept that I want, and hit enter. So negative 3.90, 0, 0.99. Notice the order doesn't matter. I hit submit answer, and there it is. That's it. I just need you to be able to practice doing that. And again, you can just do it in Desmos, but you will not have Desmos on the actual test. Just click. There it is. There it is. And in a second, when it asks for extrema, right, we can do it that way as well, and y-intercepts there. So Desmos, obviously, very, very, very easy to use, but you're not going to have that on your test. So all right, so let's go back. I'm going to go to max and min. All right, so find the minimum to the nearest hundredth. So on this one, so please remember, if you ever want to do anything cool, hit menu. I'm going to graph a function. And I'm actually going to just go up and change the function that I had so I don't have both of those there at the same time. There's my function. Notice there are no x-intercepts. A good new note there is, hey, it would be it'd have imaginary zeros, but what I want is a minimum. Whenever it asks for extrema, remember extrema is a catch-all word for minimum and maximum, but now lower bound, I want to go to the left of my minimum, hit enter, and to the right of my minimum, and hit enter. Now please note, it gives me two values, right, an x and a y, but when we say minimum value, that is specifically the output, and I want to the nearest hundredth, so 3.05. There it is. So only looking for the y value. That's it. Use that technology to your advantage. Finally, I do want to point out when we're doing increasing, decreasing here. I played with this a little bit yesterday. This looks really funky, but notice, like, determine all intervals on which the graph of f is increasing. So if you weren't in class yesterday, you can watch the video, but we talked about how we can highlight essentially if it's got what would be an overall positive slope on average, then it's increasing. So like right here, we have increase. And so you're going to want to use your interval notation, negative, infinity, right? Because we're talking about domain intervals, and so I talked about that in the videos yesterday. but I'm looking at the x only. So as we move to the left, let's do this even. I'm going to take a little screenshot here so that you can see what I'm talking about. What I would do, what we did in class yesterday, is I would highlight. So increase all of this is where I see an overall positive slope. And so what I need are the domain values. Okay. So the domain here, because it's an arrow, is negative infinity to, where does it stop? The domain value is negative 4. We always use open intervals on this. It starts back here, negative 2 is the x value, the domain value where it's increasing, and it stops increasing at a positive 2, and then positive 6 to infinity. And so those are the intervals that I want to put. The main thing I want to note here, and you may need this for the domain part later as well, so negative infinity to negative 4. When you go outside the parentheses, that's one interval. You have to hit this U, that's a union, putting things together. Technically, not actually mathematically accurate, but that's what Desmos, or not Desmos, Delta Math wants you to do. So negative 2 to positive 2, union, 6 to infinity. And there it is. So notice they actually say less than or equal to. That is not accurate. They also use the inequalities. I highly recommend the interval notation. It will help. All right. Hopefully that was helpful, and I will see you all on Friday.